This micro-credential deals with network planning and design and consists of 5 targeted skills. This targeted skill discusses cable as a transfer media. The popularity of the Internet didn't go unnoticed by cable television service providers. Cable TV was another technology that was in most homes. The TV signals themselves only constituted a small portion of the bandwidth available through the media. Cable's infrastructure was also more up-to-date than that used by the telephone companies. Cable had only been introduced in the late 1940s. Much of its expansion occurred in the 1960s and 1970s. Although it was more current, cable TV was only designed for one-way communication and needed modification to provide the two-way communication necessary for Internet service. Cable's infrastructure was also quite different than the telephone's infrastructure. Telephone companies had direct connections from the central office to each customer using twisted pair media. Cable companies ran coaxial cable from each customer to a distribution hub, and then a single coaxial cable called a trunk to the central office. Coaxial cable is made up of a single center conductor surrounded by an insulator, a foil or braided shield, and an outer protective jacket. Coaxial cabling can carry a signal a greater distance than twisted pair, and its shielding reduces outside noise and interference. To deal with attenuation and to provide enough signal strength to each customer, the signal is amplified at the distribution hubs. Providing Internet access involved creating a new channel for the data stream. In addition, a cable modem on the customer's premises had to be installed to separate the data channel from the TV channels. The modem also converted the signal into a type of digital signal that could be used by a computer. Standardization among the cable companies was achieved by creating a set of specifications called DOCSIS. The original DOCSIS specifications called for a maximum upload speed of 10 megabits per second and a maximum download speed of 40 megabits per second. Cable broadband installations are most often an asymmetric service with a greater download speed than an upload speed. This is somewhat like a digital subscriber line, DSL. However, the current DOCSIS specification, which is DOCSIS 4.0, has a maximum upload speed of 6 gigabits per second and a maximum download speed of 10 gigabits per second, and it allows for asymmetric streaming. Since its inception, many cable companies have improved their infrastructure by creating hybrid, fiber, coaxial, HFC networks. These hybrid networks have replaced the coaxial connections from the Internet to the company's distribution centers and from the distribution centers to the distribution hubs. This allows for faster, more reliable connections. Similar to DSL, the speed advertised may not be the speed received by the subscriber. There are many factors that can affect connection speed. One of these is that the service provider is only responsible for getting a cable to the customer's home or office. The customer is responsible for it once it is inside their premises. Poor installation and loose connectors can cause a loss of speed or drop connections. Another problem that can affect bandwidth is the distribution hub. The throughput at the distribution hub is fixed and shared by all customers connecting to it. This means that if a neighboring customer is consuming too much of this bandwidth, there will be less available for the other customers connected to that hub. This shared connection can also create security problems. Because it is shared, it is possible for the data stream to be seen by others and possibly captured. However, modern cable networks incorporate encryption from the customer premises, reducing this risk. Very basic explanations, benefits, and disadvantages were discussed for cable TV, coaxial cable, DOCSIS, DSL, and HFC networks in this cable micro-credential. All were instrumental in helping people work and communicate with others anywhere in the world.